Hi, hello everyone. So today I would like to introduce about a CCNA training program. CCNA, Cisco Certified Network Associative, is a completely networking course, right? Software and networking grows more and more interconnected every day. Like number of users are being connected, devices are connected, applications are connected. Right? We are using number of applications nowadays. Intent wise, some policies wide. So these all systems is growing more and more every day. To capitalize all these opportunities, today IT professionals need a broad range of skills. So that skills you can get in this training program. So this CCNA will be covered. What are the topics are being covered? Let me show you our day-wise schedules. The first few days, I'll explain about basic of network fundamentals. In network fundamentals about IPv4, IPv6, and TCP/IP functions, each and every layer with practicals like IPv4 and IPv6, how to enable communication with IPv4 and how to enable communication with IPv6 also. So once you're done our network fundamentals, then you can start basic of router and router connectivities. Like what is router, types of router, functions of router, router internal components, external components. So example, if you have a home-based routers, enterprise routers, different routers, software routers, hardware routers, everywhere, anywhere we require router, right? So where we use Cisco router, enterprise router, what type of categories is there? Like if you open externally, what are the components is there? External components of routers. Say this picture, like inside, inside of the router, this. Each and every components we'll discuss here. Similarly, external components of also. Next, the core subject is what routing part. How traffic is moving from one network to another network. How to find the best routes. If best path is fails, how to find the second best routes. In that routing part, static routing with IPv4 and IPv6. Dynamic routing with IPv4 and IPv6 both. Like in dynamic routing types also, distance vector, link state protocol, advanced distance vector protocol will be covered. See, actually, Cisco used to upgrade for every 3 years. Every 3 years, Cisco will release one new advanced technologies. If you take an example of in 2016, before we have CCNA version 2. After 2016, we have CCNA version 3. At present now, a new one is new CCNA. So what is the differences? So the new CCNA has been started 23rd February 2020. CCNA version 2 before 2016, the people who trained on CCNA version 2, the people who certified in CCNA version 2, they are certified, they are trained on only with IPv4 network only. After 2016, Cisco has been upgraded, like the people who trained and certified in CCNA version 3, they trained on IPv4 and IPv6 as well. Then what is the new thing in CCNA is, in CCNA version 2 and version 3, we have different tracks is a CCNA routing and switching, CCNA security track, and CCNA voice, CCNA wireless. So we have different tracks is here. To go for any track, so first prerequisite is a routing and switching how to done. Even if you go for advanced level of CCNP also, first the prerequisite is what? CCNA. CCNA routing and switching. After doing of CCNA routing and switching, then only you can go with the security or voice or wireless, like many tracks is there. But in the new CCNA, no more prerequisites is not required. Directly you can write the CCNP also. The starting point is CCNA recommended. What the CCNA will cover? Routing and switching will cover, security will cover, why wireless, like all tracks, the minimum basic knowledge is required. So those things will cover in a CCNA new. So we don't have any now routing and switching, security, no voice, no wireless, nothing. Only one exam, only one training program, which is CCNA. That new CCNA is implementing and administrating Cisco solutions. Clear? So let me start with some.
I had one question.
Yeah, yeah, Nikhil. Yes, yes, please.
What is the difference between the CCN and CCNP?
Nikhil, I can't hear you properly. Can you speak loudly once?
What is the difference between CCN and CCNP? Why should we do CCNP?
Oh, okay, right. See this. The CCNA Cisco certification tracks. The people who are interested to start your career in networking, the first level is a entry level. See, entry level means first step. Without any knowledge of networking domain, you can start from here. So once your entry level is done, then you can go for what? Associate level. But associate level is we have CCNA. The CCNA will see what type of technologies in the routing and what type of technology switching and wireless and security is introduction about technologies. If you go for CCNP, in NP, each protocol we have clear explanation in detail of concepts will be available actually. So we're going to become the a professional in CCNP. Not the CCNA, it's a CCNP actually. So entry level is NE, entry level, associate level, professional level, expert level. The highest is a architect level. These all are Cisco levels of training program. Now we are in CCNA. Is it clear, Nikhil? Okay. So these all are the CCNA NP level training programs. So here we are CCNA and next is a CCNP track. Switching network access. Let me explain a few things about switching. You know what is Ethernet? Generally, people will say Ethernet is a port. Ethernet is a cable, right? So Ethernet is not a port. Ethernet is not a cable. It's a technology. One of most popular physical layer technologies in a LAN. So I have a small introduction about this, like a technology originated by University of Hawaii. The rest corporations later adopted. See this point? Ethernet is the most popular physical layer LAN technology. As per IEEE standards, each and every technology have some standards. Ethernet standard is a 802.3. And types of Ethernets, Ethernet, fast Ethernet, gigabit Ethernet, 10 gigabit Ethernet, these are Ethernet families. Ethernet can support up to 10 Mbps. Let the speed of these ports and speed and IEEE standard. Space, Ethernet can support up to 10 Mbps speed. Fast Ethernet port can support up to 100 Mbps port speed. Gigabit Ethernet, it can support up to 1000 Mbps or we can call it as a 1 Gbps. 10 gigabit Ethernet, 10,000 Mbps or 10 Gbps, right? These are the speeds of ports. IEEE for Ethernet 802.3. What about fast Ethernet? Fast Ethernet is also Ethernet family, right? So this is common, 802.3. The difference is what? To define the speed, code is U. Gigabit Ethernet is also Ethernet family, common, 802.3. Difference is speed. To define the speed, AB and Z. 10 gig is also Ethernet family, 802.3, AE. These are the standards. Okay. So this Ethernet port will have on a switch, network switch. Example is a network switch. So switches will comes under layer 2 in OSI. Layer 2 device we call it. Okay. The switch is a layer 2 device, and it works with MAC address. It's intelligent device. So why it is intelligent device, I'll explain. And what type of communication switch will do? Flooding, and can support for unicast. Switch is a single broadcast domain. Right? Number of collision domains, it depends upon number of active ports. Number of collision domain depends upon number of active ports. Switch ports will work with full duplex communication. And bandwidth is fixed bandwidth. So these type of switches we have two types. One is managed, manageable switch, unmanageable switch. Yes, Nikhil, can you hear me?
It's clear.
Okay. Jafnavi, can you hear me?
I can.
Okay. Right. See, let me explain. Example, the port number one device is connected. Say one more device to port number two, switch port number two, port number three. The port numbers, PC1, port number one, port number two, 6. Every device we have MAC address, right? First PC MAC address is A1, say it's a A2, it's B1, A2, C1 and C2. Now to enable communication between the six devices, we have to assign IP address. It can be class A IP address or class B or class C. It should be private IP address within the LAN. So I'm using class A private IP address in my example, 10.0.0.10. Second computer, 10.0.0.20, 10.30, 10.40, 10.50 and 10.60. Right? Now devices are ready to communicate. Because of all IPs, all computers are connected, IPs are the same network, they can start doing communication. Now let's see how the communication happens. Switches are works with MAC address, intelligent devices. Why? Because switch maintains one table called MAC table, what we call MAC address table. MAC address table. So what does the MAC table contain? Port numbers and MAC address information. The scenario is PC1 is trying to communicate with PC6. The device 1 is trying to communicate with device 6. Yeah, Nikhil, can you find out me here which device is a source and which one is a destination? I repeat, device 1 is trying to communicate with device 6. So which one is source and which one is a destination?
A is the source and the 10.60 is destination.
Right, okay. So what is meant by source? Where the request is being started, that is a source. Where the request will end, that is a destination, right? From device 1, traffic is being generated. Source, what is the source IP address? 10.0.0.10. What will be the destination IP address? 10.0.60. So this packet is being generated will come to switch. Switch is a layer 2 device. Layer 2 device can work with what? MAC address. And now, what is the source IP? Source is the IP address. Destination is also IP address. What switch is doing is, are you coming from where? Where to reach? I can't understand. You have the IP address, but I can work with the MAC address. I don't know. No communication. So to avoid that, what your PC is doing is not only IP address, is adding MAC address also. What is the MAC address of source? A1. Then what will be the destination MAC address? Yes, please. What will be the destination MAC address?
10.60.
Destination MAC address I'm asking, not IP address. Destination
C2.
MAC address C2. Okay, how we can tell the C2? By seeing the diagram, here is showing the C2. Okay, fine. But in the real time, how we can come to know? In the diagram is showing the C2. But how PC1 can come to know about six computer MAC address is not possible now. Maybe your switch is in the ground floor, your server in the second floor. Like how we can come to know about server MAC address? So initially, we don't know destination MAC address. Then what switch is doing is going to add here all FFF is a MAC address. So all FF is a broadcast MAC address. This will be responsibility of ARP will come in the picture. Address resolution protocol. What is doing is ARP request. This packet is being generated. We call it as a frame in the layer 2. The frames are being generated, will come to switch. You know what the switch will do? A first function, first action of switch is from where traffic is coming. The traffic is learning the source MAC address. From where the traffic is coming, the device address is going to update in the MAC table. Okay. Now traffic is coming from PC1. PC1 connect to which port number? Port number 1. What is the source MAC address? A1. So it's updating here. MAC table, port number 1, A1 is updated. Like after learning the source MAC address, now I look for destination MAC address. What is the destination MAC address now? All FFF is broadcast. What switch will do? Flooding. What do you mean by flooding? And what is the broadcast? So flooding means sending a traffic from one device to all devices. Then what is the broadcast? Broadcasts are similar, sending a traffic from one to all. So there are a little bit differences. Broadcast means one to all, including the sender also. Flooding means one to all except source. So switch will flooding. Even your hubs will do broadcast. Switch is doing is floods. So this frame will send to PC2, will send to PC3, PC4, PC5, PC6, like all devices been flooding. Now after receiving the PC2, what PC is doing is going to open the packet. After opening that, who is your destination? 10.60. Okay, I'm not your destination. My IP address is 10.1D. So PC2 will drop the request. PC3, my IP address is 10.30, but your destination is 10.60. I'm not your destination. So PC3 will drop it, 4 will drop it, 5 will drop it. Then what 6 will do? Yes, I am your destination. My IP is 10.60, your destination is 10.60. What you need? What PC1 is doing is ARP request. I need your MAC address, computer 6. Please give me your MAC address. Oh, do you need my MAC address? And PC6 is giving the reply. Source 10.60. Destination 10.10. Source MAC C2. Destination MAC. Now, what is the destination MAC? Destination MAC is a ARP reply. Reply to whom? Reply to A1. Right? Are you getting my point, Mr. Nikhil and Jahanavi? Is it clear?
Yeah.
Yes, sir. Yes, sir. Sir, I had one doubt, sir.
Yes, please.
How much MAC address the switch maintains in the MAC address table?
Yeah, okay, Nikhil. Actually, it depends upon the model number to model number. So switches minimum it maintain 1024 MAC addresses. Minimum 1024 MAC address can be stored. Okay. Even if you go for some advanced layer 3 switches or MLS switches, multi-layer switches, it can be stored the more than 1024 MAC addresses also. Is it clear? Okay. The source and destination frame is being generated. A frame will come to switch. What switch is doing is, again, from where traffic is coming from now? What is source MAC address, Nikhil, now?
Sir.
Say to. Which port number is connected?
Port number 6.
Okay. Now port number 6, MAC address C2 is been updated. Now look for destination. Now what is the destination MAC address? ARP reply. ARP reply to which MAC address? A1. So A1 is already updated in my MAC table, right? Again, do we need to send the broadcast? Again, we have to do the flooding here. What do you say? No need, right? Because of here A1 port number 1 is connected, the MAC table is available, then what switch is doing is directly will send the information to computer 1. So this type of communication we call unicast. And initially we'll do what? Flooding. Once your MAC table is updated, unicast. So switches can support for flooding and unicast. Right? So if destination MAC address, if is not available in the MAC table. Yeah, please.
Sir, can you please explain me about broadcast once?
Yeah, sure. So what do you mean by broadcast means? Say here I have a switch, port number 1, 2, 3, 4, 5, 6, 7, 8. 8 port switch. It maintains the MAC table, MAC address table. In port number 1, have one device is connected, and port number 4 have one more device is connected. Port number 1 MAC address is A1, port number 4 PC4 MAC address is C1. So first computer is trying to communicate with destination. Source is A1, destination is C1. This frame is being generated. Will come to switch. What switch is doing is port number 1, A1 is connected. Now who is destination? C1. Where is C1? And which port number C1 is connected? Is searching the MAC table. Do you have the information in the MAC table, Nikhil? No. Then what switch is doing is, okay, there is destination is not available. So instead of sending, they don't know where to reach. So what switch is doing is sending to 2, 3, 4, 5, 6, 7, 8, sending the whole switch. So this we call what? Flooding. That means port number 1 is being request is generated. Remaining all ports are receiving is flooding. Broadcast means who is sending the request? Port number 1. This port number 1 also received and remaining ports. Have 20 computers in the LAN. Any one device will generate. 19 PCs will receive the information frames. That is flooding. Have 20 computers. Any one device can generate. 20 devices will receive the traffic. That is broadcast. Clear?
It's clear.
Right. Okay. Now A1 and C2 both are being updated. Now whenever A1 is trying to communicate with a C2, what type of communication? Unicast, directly can communicate, right? Similarly, port number 2, port number 3, port number 4, port number 5, all are updated. A2, B1, B2, C1, all are updated. Now, can you please tell me what type of communication happens in my switch here? Now, switch will do flooding or unicast because of my all MAC table has been updated. Now, what type of communication? Floods or unicast?
Unicast.
Unicast only because of all MAC table is updated, right? Unicast communication. The point is here, now PC3 is not responding. PC3 is not generating any requests. After some time, PC3 is not generating any request. So what switch is doing is the PC3 MAC information can hold up to 300 seconds. Now PC3 is idle, is not generating any request actually. So switch can hold information up to 300 seconds. Up to 300 seconds, if there is no request coming from PC3, then automatically B1, your PC3 MAC address has been flushed in the MAC table. Removed. Later, PC2 is trying to communicate with the 3, but there is no destination MAC address. Then what type of communication will happen here? Unicast or flooding?
Unicast. No, flooding.
Flooding will happen, right? Yes. So due to the only one piece is not responding, again all ports are being unwantedly receiving the broadcast, unwantedly receiving flooding, right? Is the problem. The switches. So it's called one broadcast domain, number of collision domains are number of active ports, fixed full duplex communication. And port number 1, if we transmission the data at the same time, if another piece is sending, you can receive it. Sending and receiving. The transmission and receiving simultaneously is possible with full duplex communication. Bandwidth is fixed bandwidth. Each port is 100 Mbps, 100 Mbps you can get. Now, port number 2 also 100 Mbps, port number 3 also 100 Mbps. Each port has what? Fixed bandwidth. Okay, so this is a switch behavior. Switch is a layer 2 device, MAC address, intelligent device, floods, unicast, single broadcast domain, full support for full duplex communication. These switches have two types. One is a manageable switch and unmanageable switch. So what was the difference between manageable switch and unmanageable switch is, if it's a manageable switch, we can assign the IP address. We can set some passwords for security. We can configure it. We can control the user traffic. In the short, we can say a switch can be controlled by some network administrators who are connected to the users. This user's traffic, we can manage it. Unmanageable switch, no configuration. You can purchase with a power connection and plug and play type action. But how we can identify which one is a manageable switch and which one is a unmanageable switch? A physical looking appearance, both are same. So how we can identify means like this. Manageable switch, an IP address can be assigned, configurations can be made, it has a console port. Unmanageable switch configurations cannot be made, IP address cannot be assigned, there is no console port. So by seeing the console port, we can identify manageable switch or unmanageable switch. Okay. The campus network, like if we take an example of one university, a campus, a large buildings or multiple buildings close to a specific area have different Cisco uses 3 terms: access layer switches, distribution layer switches, and core layer switches. The hierarchical design, all end user devices are connected to access layer to distribution layer to core layer. Access layer switches are layer 2 switches, L2. Means these switches can understand only MAC address. Based upon MAC address, these devices can function. Distribution layer and core layer, the both switches are layer 2 and layer 3. So these devices can comes under layer 2 functioning and layer 3 also. What is the layer 3? Network layer. Means this device can act like a router as well as switch. So we can this device can understand IP address based upon source IP, destination IP. The traffic can be forwarded. It maintains the MAC table. It maintains the routing table. We can configure the routing also. We can define some policies, can implement the ACLs. Like that. Okay. But how can I identify which is a layer 2 switches, layer 3 switches is the model numbers? Series, switch series 1900, 2950, 2960, distribution layer switches, fixed and modular switches, and core switches 65,000. Let's say how to configure switch. When you have purchased as a network administrator, if your task is how to connect it and how to configure it when you purchase a brand new. Let me take one console, switch console. So this switch console is available here, and switches will work with Cisco IOS. We do show version command. Here you can get the information. Cisco IOS software 12.2. It has 24 fast Ethernet ports and plus 2 gigabit ports. Like that. The next level of switch is a config terminal with shortcuts config T. You can say the host name, switch A. Like you can set the host name actually. Switch maintains the MAC table. To check the MAC table, you can use show MAC address hyphen table. So here is my port number 1 is a MAC address. So PC1 MAC address is this. Even we can assign the IP address to switch. This is the command. Interface VLAN 1 IP address. Some example 20.50 subnet mask followed by subnet mask. No shutdown. VLAN 1 interface has been activated. Change state to up. Like we can assign the IP address. As we have discussed, switch, we can set speed. We can set duplex also. Interface fast Ethernet port. Fast Ethernet port number 10. Speed. Actually, fast Ethernet port can support up to 100 Mbps, right? But I'm setting speed as a 10. Speed 10. It can support only 10 Mbps. Speed space 100 Mbps. Speed space auto. Automatically can adjust it. The duplex. If you configure half duplex, the port number 10 can support only for half duplex. If you configure duplex space full, the port number 10 can support for full duplex. But if you configure duplex is auto, depends upon the other device, your port number 10 can adjust automatically. Half duplex either, full duplex either, like this. So you can configure switches like this. Is it clear? Everything? Mr. Nikhil and Jahnavi, is it clear? Do you have any doubts?
Uh, Excuse me, Banu.
Yeah.
I have a doubt. Actually, my background was a different background. Means I am a chemical engineer.
Okay.
I don't have any knowledge in field.
Okay.
The vocabulary you are using, I mean, the words you're using, switching and routing, broadcasting, these are new to me. Okay.
Okay. Okay.
So, am I eligible to this course? Because my background was different one. I want to switch from my course to another course.
Okay. Okay. Right. Right. See, actually, there is no prerequisites for two CCNA courses. Like your background is a technical or non-technical. Everyone, everyone can start. So this is not only the course. This is a foundational course actually to start your career in networking. After
Okay.
CCNA, still we have CCNP and have CCIE, right? Like if
Okay.
you trained on the CCNA, then you can eligibility is a basic entry level jobs. Like you can say network network support engineer, like L1 engineers. Some entry level jobs are available actually,
Okay.
like this. So you don't bother about your previous any backgrounds. Can be technical graduations or non-technical graduation also, no problem. Clear?
Okay. Okay then. Yeah, yeah, clear.
Mr. Nikhil, have any doubts?
I had Hello.
Yes,
Sir, I
please.
had one doubt. Sir, you told that fast Ethernet switch, each port support 100 Mbps or switch support 100 Mbps.
Yes, exactly. Like switch ports are fixed bandwidth. If have a port number one, the each port can support for 100 Mbps. Means the PC which has connected to port number one, the data traffic and transmission with 100 Mbps speeds. If one more port is connected to, and this second port is sending the data transmission, the second port also can transmission with 100 Mbps speed. So each port has fixed bandwidth. Hubs are not like that. Hubs are with the shared bandwidth will work. Okay. So like this in manner we can configure switches and can do the practicals also. So I just shown you how to configure. I take a console of it. Clear guys? Right. Thank you.